Welcome to doassignment-ca. Here is the problem. A dataset records the number of hours studied and the corresponding test scores. Study hours go from 1 to 8. The test scores for those hours are 52, 61, 58, 78, 82, 87, 89, and 95. Part A. Plot the data and identify any points that appear to be outliers. Part B. Determine a line of best fit for all data points and write the equation in the form y equals mx plus b. Part C. Determine a second line of best fit by removing the outlier or outliers and write that equation. Part D. Compare the two lines. Which equation would you recommend for making predictions? Justify your choice with at least 2 reasons. Now, let us work through the solution step by step. We have 8 data points pairing study hours with test scores. Writing them as ordered pairs, we can already see that scores generally rise as study hours increase. However, the point at 3 hours with a score of 58 looks like it may fall below the trend line compared to its neighbors, making it a candidate outlier. Here is the scatter plot. 7 of the 8 points follow a clear upward trend. The point at 3 study hours with a score of 58 falls well below where we would expect it to be, making it a visual outlier. The outlier is the point at 3 study hours with a score of 58. Based on the surrounding data, we would expect a score closer to 69 or 70, but 58 falls about 10 to 12 points below that expectation. This significant deviation from the trend identifies it as an outlier. To find the line of best fit, we use the least squares formulas for slope m and y-intercept b. We need 4 sums: the sum of x values, the sum of y values, the sum of each x times y product, and the sum of x squared values. Building a table for all 8 points gives us the sum of x equals 36, sum of y equals 602, sum of x y products equals 2975, and sum of x squared equals 204. Plugging into the slope formula, 8 times 2975 minus 36 times 602, all divided by 8 times 204 minus the 36 squared. That gives 128 over 336, which is approximately 6.33. For the intercept, we compute 6002 minus 6.33 times 36 divided by 8, giving 46.75. So the line of best fit for all 8 points is y equals 6.33x plus 46.75. Here we see the first line of best fit drawn through all 8 points. The outlier at 3 hours and 58 points visibly pulls the line downward, reducing its slope slightly compared to what the other 7 points would suggest. Now we remove the outlier at 3 hours and 58 points, leaving 7 data points. We rebuild our table and recompute the sums. The new totals are sum of x equals 33, sum of y equals 544, sum of xy products equals 2, 8, and 1, and sum of x squared equals 195. Using n equals 7 in the slope formula, 7 times 2801 minus 33 times 544 in the numerator, and 7 times 195 minus 33 squared in the denominator. That gives 655 over 276, which is approximately 6.00. For the intercept, 544 minus 6 times 33 divided by 7 equals 346 over 7, approximately 49.43. The refined line of best fit is y equals 6.0x plus 49.43. Comparing both lines on the same graph, we can see they are close but distinct. The line without the outlier has a slightly lower slope and a higher y-intercept, meaning it starts higher but rises a bit less steeply. For the 7 well-behaved points, the second line clearly tracks the data more faithfully. Comparing the two lines, line 1 uses all 8 points and gives y equals 6.33x plus 46.75. Line 2 removes the outlier and gives y equals 6.00x plus 49.43. At 5 study hours, line 1 predicts 78.40, line 2 predicts 79.43, and the actual score was 82. Line 2 is closer, with an error of about 2.57 compared to 3.60. We recommend line 2, y equals 6.0x plus 49.43, for 2 reasons. First, the outlier is likely an anomaly that does not reflect typical performance, so removing it gives a better picture of the real relationship. Second, line 2 produces smaller residuals, that is, smaller prediction errors, for the 7 consistent data points, making it more reliable for forecasting future test scores. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.